Welcome to all in this video lecture series of computer networks. My name is Deepak Aneja, Assistant Professor, ABES Engineering College. In this video, I am going to discuss the topic IP addressing. IP addresses are also called logical addresses used in network layer, and IP addresses are unique. There are two versions of IP, IPv4 and IPv6. Every host and router on the internet has a unique IP address. The address space of IPv4 is 2 raised to the power 32, means we can connect 4 to 9 4 9 6 7 to 9 6 computers together. The IP address representation is of three types of notation we can use for IP addresses. First is dotted decimal representation, binary representation, and hexadecimal representation. Dotted decimal representation is like, for example, 122.11.3.31. Each block is of 8-bit address. This is also 8-bit address, this is also 8-bit address, and this is also 8-bit address. The total is of 32 bits. So this is the dotted decimal representation. Now in binary, we can represent the same IP address as 1 0 0 0 0 0, total 8 bit. 128.1011.3 is represented as 31 is 0 0 0 1 1 1 1. So this is the binary representation of the same IP address. Next is hexadecimal representation. In hexadecimal representation for the same IP address, this 0x represent to the hexadecimal. This is used to show hexadecimal. So for the hexadecimal representation of same IP addresses, 8, this 4, 4, this is 8, 0, then this is 0, this is B, this is 0, this is 3, this is 1, this is F. So represented as 16. The division of IPv4 addresses is of two types. First one is classful addressing and second is classless addressing. First of all, we will discuss about the classful addressing. In classful addressing, there is division of address spaces into 5 classes, that is A, B, C, D, and E. So if we assume this is the complete address space, that is 100%. So class A will use approximately 50% of the whole address spaces. Next, class B will use the 25% of whole address spaces. And this 12.5%, this is used for class C, and remaining this 6.25 is used for class D, 6.25% is used by the class. So how to calculate the range of this class A, class B, class C, and class D? So for this class A, initially 8-bit address block is used for network address. Remaining 24 bits are used for host address. The same class B, 16 bits are used for network ID and 16 bits are used for host ID. In class C, 24 bits are used for network ID, 8 bits are used for host ID. Network ID means for this 8-bit addresses we can use to connect the network, to represent the network. And in a single network, there is 2 raised to the power 24 computers we can connect in a single network. In class B, there is 2 raised to the power 16 network, or in a single network, there is 2 raised to the power 16 host we can connect together. In class C, there is 2 raised to the power 24 network we can create, or in a single network, we can connect 2 raised to the power 8 computers together. So the range of class A we will define, we can fix the first bit as 0 for the network ID. So by this we can calculate the range as minimum is all zeros, 8-bit, and maximum is first bit is fixed 0 and all ones. We can convert into decimal. This starts from 0 to, this is binary is 127. The range of class A is 0 to 127. For class B, there is 2 bit of network IDs. 2 bits are of network ID are fixed. That is 10. So the minimum is 10, 0, 0, 0, 0, 0, 0, 6 zeros. To maximum 10, these are fixed bit, and maximum all are ones. That is start from 128 to 191, 190. So for class C, there is 3 bits are fixed, 110 for the network ID. Remaining 5 bits are zeros, and maximum these 5 bits are 1. So the range is 192 to 223. For class D, for class D, class D is used for multicast address. So there is 4 bits are fixed, 1110. So to calculate the range, this 1110, 4 bits minimum are 0 and maximum 1. So the range starts from 224 to 239. For class E, this is reserved for future use, or this is used for research purposes. So in this first 4-bit are fixed that are all are ones. So the range starts from 4 ones, 4 zeros, and maximum 4 ones, and remaining 4 are ones. So it starts from 240 to maximum 255. So by this technique, we can calculate the range of class A, class B, class C, class D, and class E. To assign an IP, we use class A, class B, and class C. Class D is used for multicast addressing, and class E is reserved for future use. So on the basis of the ranges, so this class A addresses, the network ID is of 8-bit and host ID is of 24 bits. So we can maximum create the network is 2 raised to the power 8, or in a single network, we can connect 2 raised to the power 24 hosts, or you can say computers together. So depending upon the size of organization, the size of organization, we can use the classes. If we have large size or organization, means we have to connect more number of computers. So we use class A. If we have mid-size organization, we use class B. And if we have small size organization, we use class C. So for class B, the network ID is of 2 raised to the power 16, and number of hosts can connect in in one network is 2 raised to the power 16. Class C, network ID is of 2 raised to the power 24, and host ID is 2 raised to the power 8. Means we can connect 2 raised to the power 8 computers together. So the next question is, what is network? So in classful addressing, class A, B, and C is divided into network ID and host ID. So network address that defines the network itself. It cannot be assigned to a host. For example, for this network ID, this is net ID, this is host ID. So this is specific, and for host ID, all are zeros. So the first address of, of any class is represents the network itself. So the first address in a block is normally assigned to any device. So it is used as network address that represents the network itself. So the network of an organization. For example, so there is number of hosts that are connected in a network. So the IP address of this host is 115.50.15.90. And for this host, the IP address is 115.63.7.30. So for this 115.90.121.4. So this 115 represent that this IP address belongs to the class A. For the class A, the network ID is of 8-bit. So the first block represent the network. So the network address for this network is 115.0.0.0. So this IP address will represent this network of an organization for the outer world. For outer world. One more example. For example, this computer has an IP address of 115.15.0.0. So this computer has an IP address of 151.15.67.63, and this 151.15.90.90. For this 151 shows it is of class B IP address. So in class B, first 16-bit represents the network ID. So the network address for this organization is 151.15.0.0. So this is the network address of this organization. So next is what is address mask, or you can say mask. Address mask determines which portion of an IP identifies the network and which portion identifies the host. This is also called default mask address. For example, 192.15.28.16. So this 192 represents that it is of class C IP address. So class C 2 raised to the power 24. 3 blocks represents network address and 2 raised to the power 8. The last octet represents host. So for this, the default subnet mask or mask address for default mask addresses 255.255.255.0. For the default mask address for class A is 255.0.0.0. For class B, 255.255.0.0. For class C, it is 255.255.255.0. So next, we will understand what is classless addressing. So classless addressing uses the variable length subnet mask. So this is used to reduce the wastage of IP addresses in a block. For this purpose, we use subnetting, and the concept of subnetting we will study later and we will understand later what is subnetting, how do we do subnetting. So first of all, we will understand what is classless addressing. Classless addressing means there is no class. So for this classless addressing, we use the representation /n. There is some IP address like 192.168.1.1, that's /n, or we can say 192.168.1.1 slash, that may be some number that is 28, suppose 28. So this n can be any number that may be 8, 16, 24, 26, 27, 28, or anything else. So this notation /n notation is called CIDR notation, or this is used for representing the classless addressing. CIDR means classless inter-domain notation. So what it means, this /n or the /28 represents the number of ones in the subnet mask. There are total 4 blocks, 8-bit, 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 or 8-bit. So there is total 28 ones in a subnet mask, like 4, 5, 6, 7, 8 dot 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 8, 8, 8, 8, 24, 25, 26, 27, 28. So there are total 28 number of ones and remaining 4 are zeros. So for decimal representation is 255.255.255.240. So this is the address mask for the same IP address. So this 28 represents total 28 number of ones in the address mask. I hope this is clear to everyone. What is this classless addressing? There is no class. We can represent through the CIDR notation via this /n or /n, that may be any number. So next we will understand what is IPv6 address. How do we represent the IPv6 addresses? So IPv6 addresses consist of 16 bytes or 128 bits. So the complete block is of 128 bits or 16 bytes. So there is 32 hexadecimal digit. For example, there is one block F, D, E, E, colon. We differentiate this through the colon symbol AC92 colon, and these are total 8 blocks. F, 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 F. So 1, 2, 1 is of 16 bit, 16 bits, total 8 blocks, 16 bits. So the representation is hexadecimal colon notation. Hexadecimal hexadecimal colon notation. So in this 128 bits are divided into 8 sections. 8. Each block is of 16 bits. So the abbreviations that are used to represent IPv6 address, This is unabbreviated address AC81 colon 9840. This 00863210 colon 000 B B F F colon 0000 colon F F 1 2 3 4 5 6 7 8. So this is the unabbreviated form address. So we can further abbreviate in AC81 colon 9840 colon 86 colon 3210. We can remove these zeros colon. We can remove these zero A D B F F colon 0 and colon F F. This is the abbreviated. The fourth, for example, this HC81 colon 0 0 0 0 B B F F colon 0 colon F F. We can more abbreviated to this IP addresses 8681. This is colon B B F F. So in between, this is by default all are zeros. Four blocks are is of zeros. 0 colon. Total number of blocks are 8. Here is 1, 2, 3, 4. Total 4 blocks. The 4 blocks are missing. So in between these two columns, there are 4 zeros block. So this is abbreviated form. Address form of IPv6. So in the next video, we will cover the subnetting. These are the references that are used. This demo, and thank you.